Gas laws and their fundamentals are critical to understand respiratory physiology. In this video, I am going to tell you what are gas laws and how they define the solubility of gas and liquid. Hey everyone, welcome back to HM Learnings. I am Harshita, the creator of HM Learnings, where students come to clear their concept and to get the study material. Make sure you subscribe my channel. So today we are here with the video on the respiratory physiology, that is about the physics of gas. So this video is basically a very basic video which is going to deal with the different gas laws, and also it is going to talk about how the gas dissolves in liquid and how these laws are going to define or tell you that how much is the solubility of a gas in a liquid. So this is a very important topic because this forms the foundation of topics such as transport of oxygen, transport of carbon dioxide. Then there are various applications also, such as in the case of the decompression sickness, to understand high altitude physiology. Also, you need to know what is the partial pressure of oxygen in alveoli, in blood, and similarly for carbon dioxide. So if you know what is partial pressure, what is Dalton's law, what is solubility of oxygen, what is solubility of carbon dioxide, it will be easier for you to understand these topics, and that is why it is having a lot of significance. So we are going to start and this video. So basically we already know that there are three states of matter, that is solid, liquid and gas, and these states are different from each other in terms of the amount of the intermolecular forces between them, the distance between the molecules, and also there are different other properties also. So basically here we are going to talk about the solution. So whenever we talk about solution, basically the solution is having two components, solute, and other component is the solvent. So solute is a type of a component which is a minor component because you can say that the concentration or the amount of a solute in a solvent is lesser, whereas a solvent is a major one which is having a maximum or high concentration in the solution. So that is called as the solution, the mixture of the solute and the solvent. So your solute could be in either in any of these states of matter, and your solvent could also be in either states of the matter. So there could be a solution in which solid is in minor and liquid is in the major. Similarly, you could have you can have gas. Okay, you can have gas in your minor component, and you can have liquid as your major component, and you can have even gas as major and gas as minor. So there are different types of the solution which could be possible, and the type of the solution which we are dealing here is here in which the gas dissolves in the liquid. And this is the most common example which we know is the oxygen dissolve in water. For example, in the case of the aquatic environment. So we say that how the life is possible in the aquatic environment because oxygen could dissolve in the water. And also we know very known example of gas, in gas, that is the air. So it is a mixture of different gases. So we are going to deal with that how the gas dissolves in liquid. So how can you, like, you know that gas is something which is in a different state of the matter, and liquid is something which is in different state of the matter. So what happens when gas enters into the liquid, how the molecules of gas is going to incorporate between the molecules of the liquid, does the state of the gas also changes into the liquid state? These are very basic questions. So we're going to start answer these questions. First question, which defines that what dissolves in what, is something called as a like dissolves in like. Okay, so a like compound is going to dissolve in a compound which is like it. So it is a simple law that the two compounds which are having similar properties are more chances to dissolve with each other as compared to the compounds which are having distant or different properties. So here like means polar compound dissolve polar compounds, and non-polar compounds will dissolve in non-polar compounds. So like if you give an example of polar compounds dissolve in polar compounds, such as NaCl dissolves in water, and for non-polar also you have various examples, like you are having hydrocarbons which are soluble in the lipid or in the oil. So that is a non-polar dissolve in the non-polar. So what is polar and what is non-polar? So we can just have a quick look on what is polar and non-polar. So basically you understand that if we take the example of a polar compound, we have water. Okay, so water is having one molecule of oxygen, one atom of oxygen and two atoms of hydrogen. So this is the bond between oxygen and hydrogen is something called as a covalent bond. And if you talk about, this is a polar compound because there is a difference in the electronegativity between oxygen and hydrogen. So electronegativity is defined as a strength of pulling the electrons towards the atom. So if we say that oxygen is having higher electronegativity, that means that it is having higher force or higher strength to pull the electrons towards itself. So as a result, what happens, that it is going to get a negative charge, partial negative charge, and it is having a partial positive charge because electrons are being pulled towards or by the oxygen towards itself. Therefore, there will be higher electron density near the oxygen and there will be lesser electron density near the hydrogen. So it will get a partial positive charge. Similarly happens to this atom of hydrogen as well, and this is how a dipole forms, and this is a polar compound. So now this is a one water molecule. Likewise, if you are dealing with water, there will be many water molecules. So there is another water molecule here, suppose. Now this is also having the same thing, partial positive bond, partial negative atom here. So how does it will make bond with this bond? So this, if you are, so this is a negative, this is a positive. So this is, it is going to make a hydrogen bond. Now this bond is called as the hydrogen bond, which is a type of a intermolecular bond. So water molecules are held together by a hydrogen bond, and this hydrogen bond is being formed by the polarity of the molecules. Now this is which type of bond? This is a covalent bond, and in covalent also this is a polar covalent bond. Okay, so you talk about this is what a polar molecule is. Similarly, another example of polar molecule is HCl. So in HCl you can see that the chlorine is highly electronegative. So the chlorine gets a partial negative charge and a hydrogen gets a partial positive charge. And how does the different molecules of a chlorine are going to be attached with the chlorine? That with the hydrochloride, like there are different hydrochloride molecules. Okay, so how they are going to be attached? So negative one is going to be form a bond with negative positive one is going to form a bond with a negative atom, and negative one is going to form a bond with their positive one. Okay, so this is how they are going to be held together. So polar molecules are going to be held together because of a kind of an electrostatic attraction between them or by the hydrogen bonding. Both are depend upon the dipole formation and dipole formation. Then there is another polar molecule such as NaCl. So NaCl is actually having an ionic bond. So ionic bond means that it is having a positive charge and it is having a negative charge. There is no partial charges here because there is complete donation of an electron by sodium to the chloride, and chloride has completely accepted one electron. So this is a type of ionic bond in which there is donation and acceptance of the electron, but in the case of the covalent bond there is no donation or acceptance, there is sharing. Okay, so if one is more electronegative, they will be getting a partial negative and partial positive charge. But here this is a different scenario because there is total acceptance and donation of the bond. They're getting the complete positive and negative charge, and then they are held together by the ionic bond, which is an electrostatic attraction. So covalent bonds are more stronger than the ionic bond. Now non-polar compounds are something which are not having any polarity. For example, if you talk about the carbon forming a bond with a carbon, so there is like both of them are having the same amount of the electronegativity, so it is basically a non-polar compound. Like lipids, we say lipids are also the non-polar compound. Hydrocarbons are something which is a non-polar compound, so they don't have partial negative positive charges, they don't have dipole formations, and they are held together by the forces called as the van der Waals forces or dispersion forces or London dispersion forces. So now you know that what is polar and what is non-polar. So next is the what is intermolecular forces. So I told you between polar molecules hydrogen bond or electrostatic attraction is there, and between non-polar bonds are dispersion forces which are there. Now what dissolves and depends upon, like we take the example, for example, if we are dissolving NaCl in water, will it be dissolved? Yes, because NaCl is also polar, water is also polar. Can we dissolve NaCl in oil? Answer is no, because NaCl is polar and oil is non-polar. So how NaCl dissolves in water? When NaCl is added in water, it will dissociate into sodium ion and chloride ion. And there are water molecules which are there, and they are having partial positive and partial negative charge. So this oxygen atom is going to surround this is going to bind to the sodium. So they are going to form a dipole, they are going to form an electrostatic attraction between them, and likewise there will be many oxygen atoms which are attached to it. Okay, so this is how it will form a bond. So this is how it will be dissolved in water. No such bond is forming here, therefore NaCl will be separate and oil will be separate. It is not entering inside the oil. Next is, so this is how, now what we are interested is that how oxygen dissolves in water. This is interesting because oxygen is something, or carbon dioxide is something which both are non-polar, but to some extent oxygen and carbon dioxide can dissolve in water. So this is not a hard and fast rule. Oxygen is non-polar but it can still dissolve in water. Carbon dioxide is non-polar but it can still dissolve in water. So how does it dissolve in water? Like you have oxygen. So oxygen, you can say they are having six electrons in their outermost orbit. So it is forming 3 covalent bonds with the other oxygen atom. Okay, so likewise it has completed its outer orbit, but 2 electrons are going to be forming a one lone pair. So by this it is going to form a bond with the water. Okay, but this is not that soluble bond, so this will form a bond with the water molecule. Okay, and like this here will be one water molecule, so it is going to be attached to that. Okay, so like this oxygen molecule will be surrounded by many water molecules. Similarly in the carbon dioxide also there will be many molecules which are surrounding the water. So now you know how does oxygen dissolves in water, how does gas dissolves in water. It really depends upon what is the type of a gas. Is it polar? Is it whatever it is dissolving in, it is polar or not? Another thing is that what is the intermolecular attractions between them. Like the kind of interaction here is basically an electrostatic attraction. So if that interaction is possible, it can dissolve in the polar compound. If that interaction is not possible, it can't dissolve in the polar compound. It can only dissolve in the non-polar compound. Now, next question which comes into the mind, oxygen is a gas, water is a liquid. So what happens to the state of the oxygen when it dissolves in the water? Will it remain in the gas form? The answer is no. It will actually, because your solvent is in the water form, it is the major amount of the solution is in the water form. The oxygen and the water both will remain in the same state now, that is in the solvent state, which is a liquid state now. So oxygen now is dissolved in the water and you will be not able to see oxygen bubbles as such if you dissolve oxygen in water. But if you change the pressure, if you change the temperature, depending whatever is the change, the solubility of oxygen will differ. So we will talk about the action of pressure and temperature in the next slides. Okay, so till now we have understood that how the gas dissolves in liquid and what happens to the state of the gas when it dissolves in liquid. Next is what is solubility. Okay, now what determines that what will be the amount of the oxygen which will be dissolved in the liquid? What are the factors which are affecting the solubility of the gas? So dissolve is something, the action of dissolving or mixing the solute into the solvent. Solubility is defined as the maximum amount of the solute which can be dissolved in the solvent at a constant temperature and pressure. So we are going to talk about that what determines the solubility, like what is the amount, how will you know that okay, this much amount of oxygen is going to dissolve in this much amount of the liquid? What are the factors? So for that, there is something called as concentration of gas and there is something called as concentration of liquid, because you are exposing two different states, or not states, but you are actually exposing two different compounds. So definitely what amount is going to dissolve in what amount will depend upon what is the existing amount of these two compounds. So concentration of gas basically means number of gas molecules, okay, in some volume of gas. Suppose we are taking 1 ml unit volume of the gas. Similarly, we can say number of liquid molecules divided by 1 ml of that liquid. Okay, so it is a simple thing that if you are, this is the liquid, this is a beaker which is containing liquid, and air is there outside. If you are increasing the concentration of the gas molecules in a air, definitely the number of the gas molecules which are entering inside the liquid will increase. Okay, because now the number of the gas molecules which are available per unit ml of gas is higher, depending upon the other conditions such as temperature and volume are constant. Okay, so those conditions have to be remain constant. If you increase concentration, the solubility will increase. Now you keep this point in your mind, and we term to the another concept which is called as the pressure. Now pressure is again a word which is going to be used repeatedly in respiratory physiology. What is pressure? Let's forget about gas, we talk about pressure. Pressure is something which is a kind of a force which is exerted by the molecules against a surface. So we are taking an example of a balloon. This is a volume, this is a balloon, and this is filled with the gas molecules. There are many gas molecules which are being filled. So this is a closed space. The balloon is tied here. Now these gas molecules are in the constant motion. They are colliding with each other. They are going to also collide with the wall of the balloon, and when they collide with the wall of the balloon, they are going to exert some force. They are going to push the balloon wall by some energy, and that is called as the pressure. So pressure is defined as a force per unit area of balloon. Okay, so what is the total pressure which is exerted on the whole volume of the on the whole surface of the balloon will be equal to the force of exerted per unit area into the total surface area of balloon. That is going to give you what is the pressure which is exerted by the air molecules in a balloon on the balloon wall. That is defined as the pressure. Now this is a gas which is only having a single type of the gas molecules. Now imagine you are actually filling it with the gas which is having, yellow is not that visible. Okay, we are having another gas also there, gas molecules. Okay, so and you are having another one also which is in the blue color. So there are three different gas molecules in this gas which is filling the balloon. So you are having this you termed as P1. So P1 is exerting this pressure. Okay, then you are having another gas molecule which is exerting, which is P2, which is exerting again some amount of the force. Okay, this is exerting P1, and then you are having a third type of the gas which is exerting the other amount of the force per unit area. Okay, so what is the total pressure which is exerted by all these gases on the balloon wall will be equal to the sum of P1 plus P2 plus P3. This is called as the Dalton's law. Okay, and the individual pressure component is called as the partial pressure. Okay, so again I will define what is pressure. Pressure is defined as the force exerted by the moving gas molecules against a surface at any given instant. That basically at this time point, the pressure which is exerted by the gas molecules filled inside the balloon is exerting P pressure on the balloon wall. Now, if you are having the gas which you have filled in the balloon is a mixture of different gases, what is the pressure which is exerted by individual gas molecule is termed as the partial pressure of that gas. Okay, and what is the total pressure which is exerted by the gas will be equal to the sum of the individual partial pressures of each of the gases. Okay, now what is the relation between a pressure and concentration? So basically, as I said, that concentration of gas, I already talked about concentration of gas, that is number of gas molecules per unit volume of gas. Okay, so suppose you have increased the number of the gas molecules of particular gas inside the balloon. Now what will happen to the partial pressure exerted by this gas on the balloon wall? It will be higher than the before. So now what will happen, that the pressure exerted by this gas, that is P3, will be higher than the previous gas, because now there are more molecules of the gas molecule of that blue gas inside the balloon. So that means that the partial pressure of a gas is directly proportional to the concentration of the gas, provided volume and temperature are constant. This is called as the ideal gas law. Okay, so I will again repeat that concentration of gas means number of gas molecules per unit ml of gas. So if you increase the concentration of gas, the number of molecules will also increase. So they are going to exert more pressure. So as the concentration increase, the pressure is also going to increase, and therefore we say that the pressure and gas are directly proportional to each other. Pressure and concentration are directly proportional to each other, which is called ideal gas law. Okay, now the question comes, okay, we have discussed all these things, but still we don't get the answer. What determines the extent of solubility of gas? So for this, we are taking a beaker, okay, and we are having water in it, okay, and there is no exposure to air right now. Okay, now we have exposed it to the air, and air is having some partial pressure of oxygen. Okay, so you say that the whole atmospheric pressure, okay, is 760 mmHg. Okay, and out of this the partial pressure is around 159 mmHg. Now you want to know what is the amount of the oxygen which will be dissolved in the water. So how can you know? That is being defined by Henry's law, which states that the amount of oxygen dissolved in water, the concentration of oxygen dissolved in water, is directly proportional to the partial pressure of oxygen in the air to which it is being equilibrated, to which it is being exposed. So this is something which I have told you here only, before only, that if you increase the concentration of gas, what will happen? The number of gas molecules which enter inside the water will increase. Now we have replaced the term concentration with the partial pressure, and as you increase the partial pressure of the gas in the in the air, it means that the number of the gas molecules in the air have been increased. It means that the concentration of the gas molecules in the air have been increased. So more number of air molecules will enter inside the water. Therefore, the oxygen dissolved in the water will also get increased. This is called as Henry's law. Okay, and there is lot of application of Henry's law. Okay, so we will just see now what has been written in the text. Pressure of gas is a force exerted by moving gas molecule against a surface per unit area at a given instant. Dalton's law is the total pressure is the sum of partial pressure of the individual gas in the air mixture, and pressure exerted by an individual gas in a mixture of gases is called partial pressure. So if you want to find out what is the partial pressure of oxygen, and if you know that in a balloon, if the total pressure is X, and if you know that if I have this gas is also there inside the balloon, and this gives you 21% of the total pressure, so you can multiply 21% with the total pressure. So you can get the partial pressure of that particular gas. That is the partial pressure. So by this, you are having this table in which you right now concentrate on this thing. So total pressure is 760 mmHg, and if this is 79% round off, so if you multiply 79 with 760, you get 597 mmHg. Similarly, if you multiply 21% with 760 mmHg, you will get 159 mmHg. Okay, so like this you can calculate the partial pressure of the particular gas by multiplying it with the percentage contributed by that gas into the total atmospheric pressure, and this is the pressure at a sea level. Okay, now next is the ideal gas law, that is the pressure of gas is directly proportional to the concentration of gas molecules. Okay, this is the law, and P and T are constant, therefore P is directly proportional to N. N is basically the concentration number of moles. Then Henry's law is say that the concentration of gas dissolved in liquid phase is proportional to its partial pressure in the gas phase. It is directly, sorry, I forget to mention here, right here, it is directly proportional to the partial pressure of oxygen in gas. Oxygen dissolved in liquid, then this constant is being replaced by this directly proportional sign is replaced by a constant, and this constant is called the solubility coefficient. And about the solubility coefficient we are going to talk about in the next video. Okay, so how this is the calculation of the solubility coefficient of oxygen. Okay, we will talk about this in later videos. Now I have said that there is application of the Henry's law. So if you know, in the settings, in the clinical settings, we are having one test which is called as the atrial blood gas. So basically the sample is being taken from the patient, and then in the report you get PO2, PCO2. So this Henry's law is being used to tell you PO2 and PCO2. So they have the blood. Okay, they should tell us what is the amount of oxygen dissolved in the blood. Okay, they should tell this because they have blood, but they are not telling this thing. What they are telling this thing. Okay, so how they are telling partial pressure is by equilibrating that sample with the air. Okay, and then they are telling that this partial pressure which is coming in the report is something which is equilibrating with the oxygen dissolved in the liquid phase. This is the application of the Henry's law. Okay, so in today's video we have seen about the how gas dissolves, what are the different gas laws, and how they used to tell us the solubility of the gas. In the coming video we are going to talk about the solubility coefficient and also how the temperature affects the solubility of gas in liquid. So these are the references. These are two very well written books for this topic. I recommend you to read from this also. If you like this video, please like, share and subscribe my channel. Till then, keep learning.